This is a tutorial on adding and subtracting rational expressions. Adding and subtracting rational expressions with like denominators is just like adding and subtracting fractions with like denominators. If I wanted to add 2/4 to 1/4, I would just add my numerators across. I'd end up with 3/4. Same thing works with rational expressions. If I have 3x over 4x squared plus 10x over 4x squared, well, 4x squared here is a common denominator. So I can think of this as 3x plus 10x all over 4x squared. Now, 3x plus 10x is 13x. This is still over 4x squared. So when you add rational expressions and they have a common or a like denominator, all you have to do is add your numerators. Now this 13x over 4x squared has an x in both the numerator and the denominator. And x divided by x is just 1, so you can cancel out one of the x's to simplify this expression. And our final answer would be 13 over 4x. Now let's look at a subtraction problem. Here we have x squared minus 9 over x plus 1, and we're subtracting 4x minus 9 over x plus 1. Now once again, we have common denominators, which means I can write this as x squared minus 9 minus the entire quantity now of 4x minus 9, and this is all over x plus 1. Now the way to do this subtraction is to turn this into an addition problem. Take this minus sign and pretend this is a -1 in front of this parentheses. Then you would just distribute this -1 inside through multiplication. If you did that, you'd have x squared minus 9. Now -1 times 4x is a -4x, and -1 times -9 is a positive 9. Again, this is all over x plus 1. Now -9 plus 9 is 0, so those will cancel, and we'll be left with x squared minus 4x over x plus 1. So the easiest way to do a subtraction problem is just to turn it into a addition problem by distributing that -1 through the second term. Now what happens when you don't have a common or a like denominator? What if you have unlike denominators? Here we have 10 minus x over 32x to the 4th plus x squared plus x minus 1 over 6x cubed. Well, if I wanted to add 3/4 to 4/5, I would have to find a common denominator. And my common denominator would be 20, because I can get 20 from both 4 and 5. 3/4 is 15/20, and 4/5 is 16/20. Now that I have a common denominator, I can add my numerators. This would be 31/20. We're going to do the same thing when we add rational expressions that have unlike denominators. We're going to find these rational expressions a common denominator, or what we call a least common multiple. So how do we find the least common multiple of 32x to the 4th and 6x cubed? Well, to find the least common multiple, you have to find all the factors of each of these numbers. My factors of 32x to the 4th, well, first I'm going to find my factors of 32. 32 can be factored into 8 times 4, and 8 can be factored into 2 times 4. This 4 can be factored into 2 times 2, and this other 4 can be factored into 2 times 2. So my factors of 32 are 2 times 2 times 2 times 2 times 2, or 5 2's multiplied together. So 32x to the fourth then, its factors are 5 2's multiplied together. We have an x to the fourth, so that's 4 x's multiplied together. Now we need the factors of 6x cubed. Well, 6 is just factored into 2 times 3. So 6x cubed then, its factors would be 2 times 3, and then 3 x's, so times x, and times x. The least common multiple includes all the factors of both numbers, but doesn't include any repeating factors. So we have a repeating 2 here, but we would only carry down one of those 2's. We'd carry down all the rest of the 2's, all 5 of them. We carry down this 3. We have 3 repeating x's here, so we carry down 1 x for each one. And then the last x. So our least common multiple then is 2 times 2 times 2 times 2 times 2 times 3 times x times x times x times x, or 96 x to the fourth. Now this works the same for rational or polynomial expressions. If I wanted to find the least common multiple for x squared plus 2x minus 8 and 5x squared minus 5x minus 10, I would have to find the factors of both of these numbers. Now I can find the factors of x squared plus 2x minus 8. This can be factored into x plus 4 times x minus 2. If I find the factors of 5x squared minus 5x minus 10, well, this has a greatest common factor of 5. So I'm going to factor that out, and I'll have x squared minus x minus 2. This can be factored into an x plus 1 and an x minus 2. And it's still multiplied by 5 out front. So now I need to find all the factors of both of these numbers. My first set is x plus 4 times x minus 2. My second set has a 5, an x minus 2, and an x plus 1. So my least common multiple then would have a 5, an x plus 4, 1 x minus 2, and an x plus 1. Now you could FOIL this out, but until you add or subtract your rational expression, I would leave it in this form. Or I would say that my least common multiple is 5 times x plus 4 times x minus 2 times x plus 1. So let's go back to our original equation here. This 10 minus x over 32x to the fourth plus x squared plus x minus 1 over 6x cubed. Now we already found the least common multiple for 32x to the fourth and 6x cubed. It was 96x to the fourth. So I need to make the denominator of both of these terms 96x to the fourth. So how do I make 32x to the fourth equal 96x to the fourth? Well, I multiply it by 3. But if I multiply my denominator by 3, I have to multiply my numerator by 3. Now I can do this because 3 over 3 is equal to 1. So even though I'm multiplying both my denominator and my numerator by 3, I'm not changing this term's value. This will become 3 times 10 minus x over 96x to the fourth. Now let's look at the second term of my addition. How can I make this 6x cubed equal 96x to the fourth? Well, the only way I can do that is to multiply it by 16x. And if I multiply the denominator by 16x, I have to multiply my numerator by 16x. So my second term then will be 16x times x squared plus x minus 1 over 96 x to the fourth. Now because I have a common denominator, I can rewrite this as 3 times 10 minus x plus 16x times x squared plus x minus 1. And this is all over 96x to the fourth. So now that I've found my common denominator, I can just add my numerators. Now my last step would be to simplify this. So I would distribute this 3 inside this set of parentheses, and I would distribute this 16x inside of this set of parentheses. If I do that, 3 times 10 is 30. 3 times negative x is a minus 3x. 16x times x squared would be 16x cubed. 16x times x is 16x squared. And 16x times a negative 1 is minus 16x. Of course, this is all still over 96x to the fourth. Now I'm going to add my like terms and write my numerator in standard form. So it's going to look like 16x cubed plus 16x squared. Now negative 16x and a negative 3x can combine to be a negative 19x. And then we have a positive 30. And of course this is still over 96x to the fourth. This cannot be simplified anymore, so this would be the solution of our addition.